Color Management 101.
101, 102, 103.
Okay.
Yeah. It's going to start basic, but we're going to dive deep. In fact, we're going to start in the beginning where we're talking about color spaces, profiles, and what they're used for. Generally speaking, and to Apple's credit, ColorThink came up with a really good system-level implementation of color management built into the Mac. At one time, I actually saw, top secret, tell no one, I saw ColorThink at one point running under Windows. And then Steve Jobs came back to Apple, and it was Steved, seriously, because it was Mac technology. Color management itself is not an Apple technology. The ICC, and it's the International Color Consortium, although they have a French name, and I can't pronounce French, came up with the concept basically of color spaces. And color science goes back all the way back to the 1940s or
Earlier,
30s.
Yeah, it was the 30s.
Well, with the Swiss Army, men volunteers, Swiss scientists decided to test what the maximum color gamut of vision was.
What can human beings see?
Yes.
That's really what it came down to, because without giving a science lecture, the electromagnetic spectrum goes all the way from cosmic rays to X-rays, and visible light is just one part. And I like to
400 to 700 nanometers.
And what I like to joke is that if nature had given us slightly wider gamut color vision, you could see channel 12 without a TV set. So our eyes only see a certain range of wavelengths of light, and that's what the human vision gamut is.
So we don't see ultraviolet on the red, we don't see UV on the blue, but we see basically, this kind of range of color.
And some insects and birds see well outside of this range.
Yeah, which gives them, that's evolution at its finest. So the bottom line is what color management tries to do is to basically define what the color profile, if you will, the fingerprint of what a device can see.
Right. So what we're really saying is human vision can see this much.
16 million some odd colors.
A certain camera, a certain paper and ink combination, a certain screen. Each of these will have a different fingerprint. I don't like to use the word profile, but in this case, a different fingerprint, a different range of colors.
Yeah, basically the gamut that the device can either contain or display or capture or print.
Okay.
So in this case, you need profiles for input devices being scanners,
cameras,
any kind of device that is capturing like either continuous light or scanning film. Then you need to be able to do a display profile so that when you're looking at an image, it has to be, the display itself has to be profiled. And we'll have examples of kind of a high-end and an average display profiling capability. Then when you're working in Lightroom or Photoshop, you use a working space. I'm using kind of a geeky application called ColorThink. It's by Chromex, and what it does is allows you to see in 3 dimensions the gamut of the color. So going from dark to light at the top, and then the entire range of colors.
I like to think of, you use the word working space, and a working space is similar but different from a profile. So I like to think of a working space as like a bucket. That's the size of the bucket in which you're going to mix your colors. You're going to pour all your colors. And the bigger the working space, the more colors you can encompass.
Okay, so for example, in this is the front end. This is actually a Phase 1 P65 outdoor daylight ICC profile.
Right.
loaded into ColorThink. So this is the color, really, that the camera, the sensor itself, can capture.
And we should point out that those colors on your screen are just proxies for the real thing. That's
Yeah.
not the actual magenta and purple and green.
No, because
Because your screen can't display them.
correct.
So that's why it's the graph. Those colors are just showing you what's there, what region you're in,
Yes.
but the graph is actually showing you the representation.
So this is a 3D representation of a working space, and this happens to be sRGB.
Which is what a typical monitor or TV set is.
Hopefully, yes.
Okay.
Not necessarily, because some cheap displays actually can't show all of sRGB.
That's why I use the word typically.
Yeah. So then here's sRGB. Now here's Adobe RGB.
You just like to be right.
Sorry. Sometimes I can't help being right. Okay, so here's sRGB. Let me add Adobe RGB on top. Now, the Adobe RGB is set to be a wireframe so that I can see outside of the sRGB how much more color gamut there is, okay? So you can see that Adobe RGB extends considerably, and if you look at the horseshoe side, this display is much bigger.
Yep.
The problem is, if you are going to do a capture with a raw file with either a DSLR or a medium format camera, this is the colors that the camera can capture, well exceeding that of sRGB or Adobe RGB. If you use sRGB or Adobe RGB as a working space, you're starting with a large color capture and artificially clamping it, clipping it. It's kind of like a sex change operation. It just chops it off.
Okay.
Well, that's the way I think of it.
Yeah, if that's the analogy you want to use,
Okay.
go ahead.
Because the thing about it is, once you cut a color off, you can't get it back.
No, you can't.
No.
No. The point is, you can't put 5 gallons into a 2.5 gallon jug.
Correct.
Okay.
Not without some spillage.
I like my analogy.
Yes. Not without some spillage. So let me hide sRGB and Adobe RGB. Here's our camera profile again. Okay. Now let's show you what ProPhoto RGB looks like.
Bigger.
So the camera here is contained, although theoretical color comes out a little bit on the blue end. The actual sensor can't actually capture that color, so it's a theoretical color. But basically, here is everything that is in ProPhoto RGB, and it is in essence completely contained. So in terms of a working space where you want to maintain the colors that can be captured, that's why I really advocate and recommend ProPhoto RGB.
It's the biggest bucket.
Yes. Now, the downside is, and some people talk about the fact that, well, you still have red, green, and blue, 0 to 255, or in Photoshop, 64-bit, which is actually 15-bit plus 1 level. I'll talk about that later. Because the color coordinates are so widely spaced, red, green, and blue, the color space is bigger. If you work in ProPhoto in 8-bit, you really run the risk of posterization. I mean, you can posterize any 8-bit file, but ProPhoto
That's when you get those
itself-
stair steps.
Absolutely.
Yeah.
So I think one of the things that you have to really contemplate is future proofing. Right now, we have Adobe RGB displays. We're going to demo one. You know, nobody thought that you could get Adobe RGB. You can't get a ProPhoto RGB display
Yet.
But why would you want to work now in a space that is artificially limited? sRGB and Adobe RGB can work well as output spaces, sRGB for the web or screen for iPads, Adobe RGB to communicate with photo labs or other places that are color management savvy. I don't send out ProPhoto RGB to anybody unless they pass an intelligence test. And the first test is, okay, what version of Photoshop do you have? If it's not the current version, that's one check mark against. Then I ask them, what are your color settings set to? And if they don't know what the color settings are, I'm not going to give them a ProPhoto RGB. So you can't see ProPhoto RGB, but then the question is, can you print it? So what I wanted to do is to show an image that is in ProPhoto RGB. I'm going to use this in the softproof demo because it has a lot of nice, interesting colors. This is ProPhoto RGB. Now, you look at that, and yeah, there's some hot colors and stuff, right? What I want to do is actually chart the colors that are in the image. Every color in the image is being plotted as a point. And if you look at sRGB,
It don't fit.
there are a lot of colors that are beyond the gamut of sRGB.
And, you know, again, just so that people understand, we're looking at this on a MacBook Pro 15-inch sRGB-ish monitor. So when you go back to that photograph, I mean, we're seeing it fine.
Yeah.
It's just there are colors that are more saturated than this in the image than this can display.
Oh, particularly this display. Yes, because unfortunately, I don't view a laptop display as a really color accurate device. So,
But I use it just like you. On location, I
yes,
use it
on
all the time.
location, but I don't make any color critical decisions.
No.
So then the question is, okay, great. Well, what about printing? The working space, once you're in the working space in Photoshop or Lightroom, then if you're going to print it, what happens when it goes out to a printer profile? And I happen to have a profile for the SP7900, so our printer back there with exhibition fiber paper. And yes, as you can clearly see here, there are colors in that image that cannot print. But let's look at this. There are colors that can't be printed, but if you are working in Adobe RGB, there are colors, particularly out here in the oranges and the yellows, that the printer can print. Colors that the printer could print.
That are outside of Adobe RGB.
That would have been clipped off, you know, the sex change operation, chop off. You'd have lost the ability to ever print that color.
Yeah.
I think fundamentally it's really important to understand that you have input color spaces, camera profiles, scanner profiles. You have Photoshop as a working space or Lightroom as a working space. In Photoshop you can change it, in Lightroom you can't. And then in the output you have printer profiles for printing, you have display profiles for viewing, and then you have output working spaces or color spaces like sRGB or Adobe RGB. So I think that's the fundamental kind of A to Z of input, working space, output.
Let's next talk about what is a profile. We understand what a working color space is, but what's a profile? And how does a profile and a color space differ? How are they the same and how are they different?
Okay. The one thing that is unique to a working space, it is based upon a display space, sRGB, Adobe RGB. It has the same kind of characteristics as a display profile. But the one thing that is unique about the working space is that neutrals, equal numbers of red, green, and blue, are guaranteed to be neutral. Okay? That's so from black to white, equal numbers of red, green, and blue will be neutral. For an input device, equal numbers of red, green, and blue may not be neutral. Okay? It's a characteristic of the device. It's the fingerprint.
Yeah.
And equal, particularly on these printers, equal numbers of red, green, and blue will not produce neutral. So you go from non-neutral color description, color chromaticities, you transform into a working space in Photoshop or Lightroom, and then you transform out again to the output profile. Now in the case of out for the screen, sRGB, equal numbers of red, green, and blue would be the same.
Okay.
Does that answer that?
Yeah, that's reasonably comprehensible.
Okay.